Hi everyone, Jeffy here and welcome back to Around the World in Many Days. Today's episode is number 31 and it's titled Sandwiches by the Seaside. Now we haven't had a Sudoku puzzle for a little bit and now all that changes because we have a sandwich Sudoku as the name implies. Let's look at the preamble as always. So first of all this is the grid. So we have these blue numbers and then some letters and then we have some kind of gray arrows at the sides here. So let's read the rules. This is a sandwich Sudoku puzzle. Each of the 8 different letters in the grid represent a different digit between 1 and 8. A few digits have been given as is, without the letter conversion. These have been marked in blue for convenience. Fill the grid so that every row, column, and 2x4 box contains the numbers 1 to 8 exactly once. Numbers outside the grid indicate the sum of digits sandwiched between the 1 and 8 in that row or column. For example, if a row consists of the numbers 514, 38276, the sandwich sum for that row would be 7 because the sum of the numbers between the 1 and 8 is 4 plus 3, which is 7. The gray arrows with numbers are not part of the Sudoku. They are simply there to help you find the final answer in the end. And then what we're looking for here is today I have sunbathed by the seaside right next to an international airport, watching passenger planes go by. Can you guess where I am? Love, Gladys. Okay, so we're looking for a place where you can sunbathe right next to an airport. And this is the only puzzle this time, so we can dive right into the Sudoku. Let me open the grid here, and then we have Notepad as well, because we're going to be needing that to just fit it in the screen somehow. There we go. So we have letters and numbers this time. So what we need to do is figure out what number each of these letters represents, and then solve this as a normal sandwich Sudoku. But let's think about first how we would go about solving a normal sandwich Sudoku if we had just numbers in the grid. So what would we be looking for first? Now remember, we are always looking for things that are the most restricted, that have the least options. So things that would be very helpful to start with are things like this 0 here, because wherever the 1 is, we know the 8 is next to it because there are no numbers between the 1 and the 8. So these sums are the sum between 1 and 8. So in normal, if you do a normal sandwich Sudoku, obviously the normal grid is 9 by 9, so it's sandwiched between 1 and 9. And here is 1 and 8 because we have an 8 by 8 grid. But for example, this 9 isn't very useful because you could have the 1 here, the 8 here, and then this could be 2, 7. That's 2 plus 7 is 9, or it could be 3, 6. That could be 9, and it has a lot of options. Or it could even be 2, 3, 4 is 9. So this could be the 1 and this could be 8, for example. That would be a 9. So 9 isn't really useful to start, but this 0, for example, doesn't have many options. Things like that. Now, this is not a normal puzzle. This has these letter conversions, and that's where we have to start here because otherwise we don't have much to go on. We only have like a few numbers here. So we have to figure out what these numbers represent. And that's why I have this notepad open so we can keep track of what each number can be. So first we should just write down what letters we have here. So we have an O, U, M, H, A, that's all from the top row, E, C, that's 7. What's the last one? B. We haven't had B yet. Okay, so what can each of these numbers represent? Well, for example, M is here, and A and U and O and all those letters that appear as a sandwich sum digit, none of those can be 1, because if you have 1 as the digit here, that means you're going to have to put 1 between the 1 and the 8. Well, that's impossible because you would be putting another 1 on the column here, or the row in this direction. So any letter that's that appears outside the grid is not going to be 1, so it's going to be 2 plus. So M is 2 plus, A is 2 plus, we have H here 2 plus, O and U are 2 plus, E and C are 2 plus. So that's the starting point to realize that only B, in fact, can be the digit 1, and therefore B is 1. Now, we could be marking these with like little numbers here, but I think I'm gonna. I saw the guy who solved this, the person who solved this, used these black numbers, and I really liked that stone, so I'm gonna steal that. So I'm going to just replace every B with this 1, so we can forget about B entirely and just think of these as 1s, because we know B is going to be 1. So is that all the B's? That is all the B's. Okay, so that's our starting point. And now we know these all are 2 plus. Well, we know something else now, because now this is 0, and remember we talked about 0 being the most restricted. Well, now the 8 is restricted to two locations on this column, because there can't be any digits between the 1 and the 8. So 8 is either here or here, which is somewhat useful, but we can actually do better than that, because 8 cannot be here. So if we put an 8 here, remember we need to put a 4. Some of these 4 digits would be 4. Well, that's clearly impossible. The least these could be is 2, 3, 4, 5, and that is, well, more than 4, let's just say. So this is not 8. So the only way to make this 0 work now is this being 8. So this is now our 8, and that means that E and M cannot be 8 because they are on the same row as this 8 here. So M and E are actually between 2 and 7. There might be a clearer way of showing this. Maybe I should just write every number that these could be, because there aren't that many numbers, right? So these can be all the way to 8. And all these can be just all the way to 8. Is that any clearer? You tell me, but I'm just going to zoom in a little bit. Yeah, that's a lot of options still for each of these. I mean, 8 isn't all that restricted. Even if these can't be 8, which they can't, 8 still has 5 options. So not all that useful, but let's see what else we can decide here. So how about this 9? Now, the 1 on this row is not going to be here. M can't be 1. It can't be here because of this one. Could be either of these. Could be 1. And this can't be 1 because this isn't a 0. And it can't be 1 here because we don't have a 9 digit, because this is an 8 by 8 Sudoku. So 9, E can't be 9. E has to be between 1 and 8. So if 1 was here, we would have to have E equals 9, because the 9 is the sum there. So in fact, we know that the 1 here is limited to these 2 positions here. And I wanted to show you guys something about this Penpa. I've been doing 30 of these videos and using Penpa each time, and I only now realized I don't have to scroll back and forth to change this. You can use the tab button to change between these modes. Didn't know that before, and now I do. It's awesome. So we can actually do this corner pencil mark, indicating that 8, not 8. What am I doing? 1. 1 is in one of these positions. Did I say 8 before? I meant 1. 1 can't be anywhere else on the row except these 2 positions. Okay, so that's somewhat useful. We know where the 1 goes in this box. How about Does this 1 limit anything else? These H and C can't be 1, but we know what the 1 is already, so that doesn't actually give us any more information. But we can start thinking about where the 1 is here on this row. So 1 can't be any of these 4 because the 1 in the box is already determined. It's one of these two. So 1 can't be here. 1 can't be here because of this one, and it can't be here because of this one. So 1 in this on this row here is actually limited to the just here or here. It's two options. Now this is a bit tricky because none of these 3 can be 8s. So this m would be a pretty large number. Let's see if it actually works. If this is 1, the closest the 8 can be is here then, because none of these can be 8 because of this 8. If this is 8, the smallest number that we can put in these 3 cells is 2, 3, 4, and that's 9. And we can't have a 9. We can have a 9 as a sandwich sum like we have here, but we can't have m be 9 because m is in the grid, and these are numbers 1 to 8. So this can't be the 8, and obviously nothing closer to the 1 can be 8. So this is impossible. This cannot be the 1, which means we actually have 1 here. This can't be it because we couldn't put 8 anywhere here. So it's here. 1 is here. Now, does that help us somehow? Now the 8 on this row again can't be here. So it has to be in this box somewhere. Well, we just showed that we can't have 3 numbers adding up to this m because m is at most 8. So this can't be the 8. So 8 is here or here. Can't be here because this m can't be 0. M has to be between 1 and 8. And in fact, m has even fewer options. Those are the options for 8. For m, I should say. So between 2 and 7 now. Well, this can't be the 8 then. So it's one of these two. If we put an 8 here, that doesn't work. If we, well, let me just show you briefly. So if we put an 8 here, this is wrong. This C would be whatever this M is, but we have 8 letters and they're all different digits. That was in the rules. So we can't put C equals M. So that means this is not 8. And if this isn't 8 and this isn't 8, we only have one place where the 8 can go, and it's there. So 8 is here, which means C plus H now equal M, which restricts all of those letters. So M is at least 2 plus 3, which is 5. So it can't be 2, 3, or 4. We can remove those. And also C can't be 8 now, or 7. So the most this C could be is 6. It can't even be 6 because H can't be 1. So these could be 2 plus 5. The most the C could be is 5, because if M is as big as it can, which is 7, if this is as low as it can, which is 2, this is still only 5. So 5 is the maximum C can be, and it works similarly both ways. If C is the lowest it can be, which is 2, this is 7, then H can be at most 5. So we can remove everything higher than 5 from C and H. Okay, now that restricts our 8 somewhat, but we still have 3 options for 8. 8 would be the best to get here right away, because the 8s and the 1s are the ones that determine our sums here. So getting the 8, getting which letter is the 8 would be very useful, but we don't have it yet. Still have 3 options, A, O, and U. Now then, can M still be 5 is the question. So C and H can both be 2, 3. So it is actually possible for M to be 5, 5, 6, or 7. All right, then let's look at this column. So U now is this square plus this square. This is the sandwich sum for this second column. Well, that's at least 2 plus 3. So U, similarly to this M, can't be 2, 3, 4. Now it can still be up to 8, 5, 6, 7, or 8. Yeah, you can make these. For example, 2, 6 would be 8, and this would then be 8. Or 3, 5. Okay, so that limits the U a little bit. Now, do we have any digits that are very restricted? 2, 3, 4, still 4 options. 5 can be anywhere. 7 can be in a lot of places, and 8 still has plenty of options. Okay, so not that useful right away. Let's look at, I'm thinking about this row here. So the 8 on this row, because we need a C, which is between 2, 3, 4, or 5. So it's at most 5. So this could be the 8, but none of these can be 8 because we would have too many digits adding up to C. So this can be 8, or this can be 8 if this is C, and this can be C because there's no C in the column. So one of these is the 8. But that doesn't seem to be all that restrictive, is it? Maybe let's look at this bottom row. Maybe that's the more useful place to go, because we have a 4, and 4 is a pretty low sum. 4 is either just the 4 or it's 1 plus 3. There's only 2 options there. Now, if it's 1 plus 3, this C can't be 1, so it would be no, actually it can't be 1 plus 3 because 1 is the sandwiching digit, so nothing inside can use 1 in any way. So in fact, we know immediately, and we could have done it sooner actually, that this sum is going to be just the number 4. Well, there's only one way to put it. We can't go this way because not enough room. So the 8 has to be here and the 4 has to be here. So that's an 8. And I'm going to, now we know C is 4 because it has to be this 4 from the sum. And I'm going to remove that option from all of these letters. And I'm going to mark every C as 4. A lot of C's actually, and these should be useful. These sums that are small numbers. In fact, was that all C's? I think it was. Yeah. So now, similarly to the previous one, we know this can't be 1 plus 3 because 1 can't be inside the sandwich. So this is again just the 4, and it can't be on this side because you put an 8 there, that's a 0, and that can't be a 0. So the only place for the 8 is here, and that's a 4 then. Now then, we still don't know what letter this 8 is. But here we have something in the grid. It's not a digit, but we do know that this H, whatever number it is, and it can be 2, 3, or 5, it must go in here because that's the sandwich sum, and we only have one cell to do it. So that's a H. We don't know what that is yet. Can we figure it out? Well, from this 9, we do know something about the H. So we know that either this plus this, H plus E, is 9, which would mean that the 1 is here, or H plus E plus this is 9, which would put the 1 here. So H can't be very high. Oh no, but it can actually still be even 5, because 5 plus 4, no, it can't be 5, can it? 1 plus, can't make these 4, because 1 plus 3 is not allowed. This would be another a second one. So if we put a 5 here, I don't think it works. 5, if 1 is here, this would be 4, and E can't be 4 because C was already 4. If we put a 5 here and the 1 here, then these two have to add up to 4 without using 1, and you can't put two 2's there. 2 would break the rules of Sudoku. So 4, the H can't be 5 actually. So H has to be pretty low. That said, E could still be high. If this is 1, this is 2, E could be 7. That's still fine. Let's see. H is actually here, so we can actually use this probably. Can we? This is 1 and 8. We know the 1 and 8 on this row. We know one of the digits inside is 4, and the other is a H. So we know M is either 2 plus 4 or 3 plus 4. So it's either 6 or 7. So M can't be 5, which is somewhat useful, but doesn't crack this open right away. What about what are the columns, the rows we haven't looked at? So this 4 is very restricting on the placement of the 8. So 8 can't be here because of this 8. It can't be here because of this 8. And obviously if 8 is anywhere here, we have way too many digits summing up to 4. In fact, put it much more simply, 4 has to be one digit because we can't have 2 plus 2 or 1 plus 3, as we showed before. So 4 has to be here. And this has to be the 8 now. And that gives us the letter that which is the 8. So here we have U being 8. So I'm going to replace every U. Let's just make U 8 first. And then replace every U with an 8. Is that it? Yeah, I think it is. So now we know this was the 4. We know U is 8, so we have an 8 here. And we know what number, what sum this column has. So if we have a 1 here, then the sandwich sum is H, which is 6. But H can't be 6 because the only options for the H are 2 and 3. So this can actually not be 1, and the 1 in this box has to be here then, because that was the only other option. Now, still, do we know what this H is? H plus E equals 9. We don't know what they are, but we can limit this E. So it's either 9 minus 2 or 9 minus 3. So it's 6 or 7. 9 minus 2, 9 minus 3. Yeah, okay. That was harder than I thought. Yeah, 6 or 7. So E is 6 or 7, but M is also 6 or 7. So we have a 6-7 pair, essentially, in these options. So none of the other letters can be 6 or 7, because that would be a second 6 or a second 7, because these two both take 6 and 7. So we can remove the options from these. So that means one of A and O is 5, and then the other is either 2 or 3, and the other 2 or 3 is H. And then we have an ME being the 6-7 pair here. Now then, what else do we know? We know, oh, actually we've had this from, I think, the beginning of the puzzle here, this 1. Yeah, we placed this A pretty early on. This A has been there for ages. So if this is the sandwich sum, this has to be an 8. That was pretty simple. And this 4 again, 4 has to be one digit. We've shown that at least 3 times now. So it has to be 4 here or 4 here. And that would mean 1 is here or 1 is here. But 1 can't be here because of this one. So the only other option is 1 here and 4 here. All right. Now, does that mean this sandwich sum has to be just M? And the 8 being here then? Not necessarily, I think. This could be, for example, 2 plus 5. except yeah, that we put an 8 here. So we can't put an 8 anywhere here, and obviously m can't be a sum of 3 digits, and we couldn't put an 8 here anyway. In fact, 8 can't be anywhere here. Obviously 8 can't be here, very obviously, because there's an 8 here. In fact, we have an 8 on all of these rows. So 8 is out, so it's either here, which it can't be because m is not 0. Only option is here, 8. And m is the sum, which doesn't resolve itself. M equals m doesn't tell us anything. But we now know where e goes here. So e must go between these, because that's the sandwich sum. It must go between the 1 and the 8. Now does that limit our options for e? E can't be 4 now, but it doesn't seem to remove any options for the e because it's 6 or 7 anyway. Okay, but now we have 8 in all of these columns and 8 in 3 of these columns. So 8 is going to be, the final 8 is going to be here. Can't be on this row, can't be in these columns. So 8 is here. Now we don't have a sandwich sum here, so we don't know where the 1 goes. It could be all the, well, it can't be there, but it could be anywhere because we don't have a sandwich sum to limit it. But from this side, from the column side, we know that O, which is the sandwich sum, must now be this, which is 3. So O is 3, which means now I'm going to come back to marking those because I want to mark the O's first. O being 3. So this is an O, this is an O. Yeah, and that's it. And now this 3 means that, first of all, A isn't 3, and now H isn't 3, which makes H 2. So let's mark that as well. H is 2, 2, and we have 2 here. And that's all the H's, and now we know A can't be 2 as well, so A is now 5, and this should now resolve itself pretty soon. Still don't know M or E, but from this sum we do know it. 9 is 2 plus what? That would be 7. So E is 7, and then M would be 6. So E's are 7s. 2 plus 7 is 9, so that's correct. E is 7. This is 7. Do we have E's? No, that's it. And M's are 6. So 6, 6, 6, 6, 6, 6, 6. A lot of 6's. And now, from this point on, we just have a regular sandwich sudoku. We have all the numbers that we need. So we should be able to finish this off with just sudoku. Let's see. Did we do all the sandwiches? So this is 8. We haven't done that. So that's either 2 plus 6 or 3 plus 5. Can we do any better? This can't be 2, but this could be 2. No, this can't be 2 or 6, so it's 3, 5. So 3, 5, 3, 5. That's a 3, 5 pair here, which means what we need in the column are 2, 6, 7. So 6 can't be here because of this, so that's a 6. And 2, 7 in some order are here. What about, did we do this sandwich sum? We haven't done it yet. So here we have an 8, and this can't be a 1, this can't be a 1, so the 1 must be here. That is the sum. So we have 6 in the middle, and that's the sum. So that was the 1. Now we don't know this sum, so we can't disambiguate this 2, 7 based on that. Let's look at this sum then. This has to be 6, and we have one square there, so that has to be the 6. Then we have 2 as the sum here, that is between these. 5 as the sum here that we had. 0 as the sum here that we had. These are next to each other. Then we have 6 as the sum, so that's that. So we've done all the column sums. Let's look at the rows. So 7, that's done. 4 is done. 4 is done. 6, this 2 plus 4, that's done. 9 being this 2, 7, that that's done. 4 is done here and 4 is done here. So all the sums have been done. So in fact, now we can ignore the sums and just solve this as a Sudoku. And it shouldn't be too difficult. Where does 2 go here? 2 can't be any of these squares, so 2 goes in the box, must go there, which means that this is not 2, that's 7, that's 2. In this box we need 5 and is it 7? 5, 7, somehow still don't know where those are. What about in this row? 1, 2, we need 3, 4. So 4 can't be there, it must be there, and 3 goes there. And now this box only has one number left, that's 3, so that goes there. This box has 2, 5, and 2, 4, and 5. So 4 and 5 are already taken in this column, so this must be the 2, and 4 and 5 here. Well, 4 can't be there, so 4 must be there, and 5 must be there. Still don't know these two. What about this column here? This third column. We need 3 and 7, and 7 can't be there, so that's 3, that's 7. That 3 makes this a 5, and thus this a 3. And now here we need, in this box, we need 2 and 5. It looks like 2, 5. And then that makes this, what's the last number of this column? 7? Or this box, in fact. 7, yeah. So what about this box? 4 is here, so 4 in this box can't be here or here. That must be the 4 here. And the remaining numbers in this box are 3, which can not go there because of this 3. So 3 goes there, and then 5 here. 5. Okay, then we have, what about this column here? So we need 2 and 6. 6 can't go there, goes there, that's the 2. And in this box we need 2, 5, 7. 7 can't be here. Let's just mark all the options. 7 can't be here, that's 2, 5. 5 can't be here, that's 7 can't be here either, so that's only 2. So that's 5, that's 7. What's the last number in this column then? 1, 2, 3, 4, when you have 5, right? So 5, that solves this, so that's a 7, that's a 5. In this box we need 3 and what's the other one? 7. So 7, 3, and then we still need to figure out these two. That's a 5, so that can't be another 5. That's 2, that's 5. Let's just check that we are correct here. And it doesn't show you the message that is correct because I think it doesn't recognize these black numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8 on every row. Yeah, I think we're done. And we'll know if we did it when we find the final answer, obviously. So now we've solved the grid, hopefully. And all that's left to do is extract some kind of answer from this solved grid. Now, we didn't have any instructions on how to do this, but we did have something that we haven't used yet, which are these arrows. And it just said that these arrows help you find the final answer in the end. So let's look at what this could mean. Now this is a 1, this is a 6. So these are digits that are in the grid. We have a 1 here and we have a 6 here. So and this goes for 4 cells. So if we look at these 4 digits from the 6, we would get 6, 5, 2, 3. And if we translate that into these letters, back into these letters, that would be 6 is M, 5 is A, 2 is H, and 3 is O, not 0. And then we have from this one. So starting from this one, 5 down would be 1, 7, 5, 4, 2. So that would be 1 is B, 7 is E, 5 is A. Can you see where we're going? 4 is C, and 2 is H. So this looks correct, doesn't it? Maho Beach. And we were looking for somewhere where you can sunbathe right next to an international airport. And this is, in fact, the correct answer for this puzzle, Maho Beach. And we can just see what that is then. So let's see our answer here. So Maho Beach is in Saint Martin in the Netherlands, in the Caribbean Netherlands. And that's a beach where the airport is right next to the beach. So these airliners go right above the beach, which is pretty cool. So that is our current destination. And let's look at the map as well. So last time we were in this huge forest on Puerto Rico. And now we're going further east. And we're in St. Martin, on the Dutch side of St. Martin, on Maho Beach right there. And if we zoom out a little bit again, we have to look every time we have to look at the whole picture because I like looking at it. So here we started in Africa and now we are in the Caribbean, still in the Caribbean. Last 3 places have been in the Caribbean Sea, or in or near the Caribbean Sea actually. So that's where we are currently, and that was episode 31. Now episode 32 is going to be a bit different again. It's titled Where's the Puzzle? And that's actually all I'm going to say about that because it's pretty different than what we've had before. But I will see you for episode 33, and thanks for watching.